Homework problem 2A. A sample of nitrogen gas has a pressure of 2.5 atmospheres at a temperature of 25 degrees Celsius. What temperature is required to increase the pressure to 4 atmospheres, assuming the volume is fixed and the amount of gas does not change? Alright, so in this case we have a before and after situation. So we have to ask ourselves, what is the question? And it asks, what temperature is required? So what is the temperature to increase the pressure to 4 atmospheres from 2.5. So it's not a bad idea to identify what we have. So a sample of nitrogen gas has a pressure, so an initial pressure, at a temperature of 25 degrees, and it says, oh, we're looking for the final temperature, so there's our T2 that we're looking for. Required to increase the pressure to 4 atmospheres, so P2. Assuming the volume and the amount of gas does not change. So N and V are fixed or remain the same. Don't have to do this. Probably not a bad idea to do this. Like write down all the variables that you know. Oh, PV, yeah, and T. And then do the same thing for the 2's. So P2, B2, N2, and T2. So here's what I know. So looking at the pressure, my initial pressure was 2.5 atmospheres. My volume says that it remains fixed, so V1 is actually equal to V2, doesn't change. My number of moles, or the amount of gas, also does not change, so N1 is equal to N2. My initial temperature is 25 degrees. Make sure you add 273 to that, so 298. Okay, and then my final pressure is 4 atmospheres, so the pressure has gone up or increased. V2 again is equal to V1, as well as N2 is equal to N1, and T2 is actually what we're looking for. All right, so here is the information that's been given to us in the problem. So the question wants to know, what is the final temperature? So this is one of those fun situations where you have a before and after. All right. Now you get to use PV equals nRT twice, but you only need to rearrange the initial set of variables or the set of variables that are completely given for you. Like in this case, we know we have a P1 and a T1. So in that case, my initial set is all the information I've given. My final set has an unknown, so I don't want to try to rearrange for that. However, I do want to be mindful that since I am looking for the final temperature, I need temperature in the numerator. I need it on top in the math expression. So, knowing that I have a pressure and a temperature and everybody else remains the same, I need to rearrange these variables so that T remains on top. So, and get all the known variables to one side, all of the variables that don't change to the other side. So in this case, T, or T2, is what I'm looking for, so I want to divide by P1 on both sides. So now my equation looks like this. V is equal to NR T1 divided by P1. Okay? So now I have all my initial set on one side. Now notice I didn't say left or right, on a single side. Then I want to get all of the things that don't change to the other side of the equal sign. So I'm going to divide by my number of moles and my constant on both sides. So now my equation looks like this, where I have V over NR is equal to T1 over P1. Okay? So that is how I want to rearrange this. Now, this doesn't change. Also, I will do the same steps for my final set of conditions, making sure that T is on top. So knowing that I'm going to do the same exact steps, or dividing by P and dividing by NR, I can make this real easy and just say that, okay, my final set of conditions looks the same as my initial. Since this doesn't change, I don't need to worry about it. Okay? It is a true statement that those things are equal to T1 and T2 over P1 and P2. I get it. However, we just don't need to worry about that, all right? So now that we have our variables, the initial set of conditions and the final set of conditions arranged in the way that we want them, now we need to rearrange it so we can answer the question. So since we're looking for T2, I want to multiply by P2 on both sides. So now my equation looks like this, where I have T1 over P1 is equal to, times P2 on top is equal to T2. Okay? So now that I have that, now I can plug in my values. And this is the hardest part of the whole problem, getting your variables rearranged in such a way that you now have this set of conditions set up. And then from here, we can just plug those in. See if I can move those out of the way. Let's not. Okay. So what is my initial temperature? It is 298. 298 Kelvin. My final pressure is 4 atmospheres. And that is divided by my initial pressure, which was 2.5. Which is 2.5 atmospheres. So then I can look at my units and say, okay, well, who cancels here? Obviously, my atmospheres cancel. And then we can just plug and solve. So 298 times 4 divided by 2.5. And that gives me 476.8. So we'll say that's 477 Kelvin. And notice that it is in Kelvin. Okay. All right, let's look at 2C. Okay. 2C asks, the volume of a sample of gas is 200 milliliters at 275 Kelvin and 0.891 atmospheres. What will the new volume, so here's our question, so what will the new volume, so we're looking for V2, of the gas be at T2 and P2? Now, what's cool, really cool, giving you kelvins, which we don't have to change, but we do have to change the degrees Celsius. I gave you atmospheres and kilopascals. You need to convert to one or the other. Doesn't matter which way you go. Okay. So what we need to do is we need to rearrange the variables. Actually, I'm going to identify the variables first. So let's go ahead and do what we did like on the last problem. So P1, V1, I'm sorry. Let's go N1 on that. T1, and then we'll go P2, V2, N2, and T2. Okay. And let's put some values in there if we have them. So P1 is 0.891 atmospheres. I'm going to move you over. V1 is 200 milliliters. And I'm going to go ahead and change that to liters. So it's 0.2 liters. My N1, I don't mention anything about it, so I'm going to say that it's equal to N2. And that is a safe assumption. And then T1 is 275 Kelvin. My P2 is 98 kilopascals, 98.5. And I am actually going to convert that to atmospheres because I am a big fan of atmospheres. So 101.325 atmospheres. And let me get that real quick. So that's around 0.972 atmospheres. Okay. My V2 is what I'm looking for. My N2 is equal to my N1, and my T2 is 77 degrees. So 77 plus 273 is, what is that, 350? Let's double check that. Yep, so 350 Kelvin. All right, so we have our values there. Now, what we need to do is rearrange our variables. So again, PV equals nRT, and we know our pressure, volume, and temperature. Again, those are the variables that are defined, given to us in the problem, or what we're looking for. Now, since the question is asking for a volume, we need to make sure that when we rearrange these initial set of conditions, that volume stays on top. All right, so since volume's on top, that means we need to divide by T1, and we're going to leave N and R alone. We're not going to touch it because it by itself doesn't change, so we don't need to do anything with it. So now we got PV over T is equal to NR, and again, these are all initial sets of conditions. I would do the same thing with the final set of conditions by saying, okay, since this is how the initial looks, that's, if I do the same arranging for the final, I'm going to get the same thing. So I'm going to go have P2, V2, T2. Okay. Keeping in mind that N and R do not change. So there's our equation. We've got P1, V1 over T1 is equal to P2, V2 over T2. Now, since we're looking for V2, that means we're going to multiply by T2, and we're going to divide by P2. Okay, we need to now get all the known variables, or variables that are defined, to the same side. So now my equation looks like this, where I have P1, V1 times T2 divided by T1 times P2. Okay, and that is all equal to, equal to V2. Okay, so once you're at this point here, now we can plug in. So again, I'm going to rewrite this. And I believe we have all of our variables already converted the way we want them. So now it's just a matter of being careful and plugging them in correctly. So P1 is 0.891, and that is in atmospheres. My V1, which is 0.2 liters. My T2, which is 350 Kelvin. You have to be very careful that you don't mix up your temperatures, which is a common mistake that a lot of students will make. My initial temperature was 275. And my final pressure is 0.972 atmospheres. Let's cancel like terms. So atmospheres, Kelvin, we're left with liters, which is our volume. So in this case, V2 is equal to, let's calculate that. Around 0.2, 3 repeating, and that's liters. And I'll let you take a look at that.